Thank you so much to the panelists. I'm Genevieve Marquis from the Geological Survey of Canada, and now it's the time for a dialogue with the participant. And we are already receiving some questions. So one of the first question we receive, it's from Austria, and the question goes like that. How is the development of a European battery industry and e-car industry impacting resource development and mining in Europe? Do you have any pointers for the geoscience research for critical minerals, and any sign of exploration, development, investment is increasing on that? So this is an open question to presenters and panelists. If you have any points to present on this topic.
Well, perhaps this is Daniel once again. Perhaps I can try to answer at least this question partially. We know that the European Green Deal, as someone has already mentioned, means that Europe wants to be a carbon-free continent by 2050. Or climate neutral, if you want to call it that, and ideally, all the energy transition topics that are being branded about, or to do with the electrifying of cars, and obviously the lowering of emissions. Now, we all know that information is key to stockholders and to stakeholders, and obviously the automotive industry, although it has very large plans of electrifying their fleets by such and such a date, or providing such and such platforms, we really are in the dark as to exactly what is going to be done in relation to that. And having said that, everybody wants to drive the next electric car, but they also want to drive the next electric car that does not only drive for 200 kilometers on one battery charge. They want to drive the next electric car that drives for 2,000 kilometers on an electric charge. And so these are all things that we as exploration geologists, we can only try to find the raw materials that can provide the next better battery on the market. However, the better battery is also something that is shrouded in mystery. Which is the better battery, and who is going to develop the better battery, and who is going to be the developer of this better battery? Are we going to stick to electric vehicles? Are we going to go the hydrogen cell way, or are we going to go some other route? And this is something that, because of all these unknowns, we can really do not know the answer, and I cannot myself answer that question any further.
Well, thank you so much for your pointers on this question. We're receiving other question. One question is about the list of critical minerals in your respective country. Some presenters and panelists mention some critical minerals in their own country, but is it clear for everyone or for every country that right now, do you all have a list of critical minerals? And if not, do you know why?
This is Saku Vuori from Geological Survey of Finland. May I have a word here? We don't have a list of critical raw materials in Finland, but we are planning to have cooperation with Nordic cooperation in order to find such a list. We are primarily following the EU critical raw material list when we are doing, let's say, geological mapping and so on, consider what we do. So that's the main principle. So I think that's a good starting point for our work. So we haven't seen so far so strong a need for national list. So as being member of European Commission.
Thank you, Seku. Any others who would like to take this this question about the list of critical minerals?
Hi there, Taufik here from South Africa. Maybe I can also jump in. So from our side, we are busy compiling such a list. So especially because we see this, let's say, a market change. So in South African context, you know, we often focused on, let's say, the classical minerals, gold, platinum, coal. But now we see the shift towards obviously critical minerals, and therefore we're now also trying to adjust these type of, let's say, prospectivity maps and also lists that are associated with that. So this is definitely something we're moving on now, and especially with regard to the work that we're doing in most of Africa. So we do a few projects as well in Central Africa. So we are hoping to produce number one, a national-wide list like this, and also perhaps a continent-wide list as well. Thanks.
Thank you. Is there someone else who would like to talk about their list of critical minerals?
Yes, if I can just add something. In France, at the Belgium, we have a list of critical materials, which is quite similar to what we have in Europe, but it could differ in some minerals regarding mostly the needs that we have in France.
Thank you. Thank you all for your and for additional information on the list of critical minerals. In some presentation today, we heard the importance of building capacity. Today, we're really fortunate to have around us presenters and panelists who are managing geoscience research, and many of us are interested to know what kind of capacity and new skills you're looking for when developing your geoscience research programs. Can you tell us a little bit more about the capacity of the next generation of geoscientists needed for the research on critical minerals?
Okay, can I come in there?
Yes, absolutely.
Okay, in terms of the need that has actually shown in the trend as far as the discovery of minerals is concerned, and also making sure that you build capacity. In the trend that we have, we've been knowing that as a geologist, you go to the field and then you basically discover the minerals potential that the country or the landscape might have, but that is not adequate because there is also need to be able to have more understanding in terms of when you do the integration of the or interpretation of the results or the data that you are bringing on the table. And also we have also seen another presenter, I think is it from Finland, they were showing the approach they're using in terms of how to acquire the data, and then you also do use technologies like machine learning. So basically in the trend of nowadays is that technology, or probably I would say using machine learning in terms of having to advocate to how you integrate and how you synonymize the data to make sure that it can be able to show more features of what you were not able to do from your own results or your own perspective. It can be more enlightening. So in terms of the skill that is required nowadays, it's not just only knowing how you can be able to depict that if you use the modeling of you model the data, this is the type of approach of the results you get from the modeling. But if you know the technology of also applying the technique of even using the type of system, and then maybe you basically use a machine learning to delineate the data and come up with more findings and more results. So that is the building capacity that we are referring to, because that is a way of also making sure that every bit of data that is there, when you're saying you are managing it, you are disseminating it, at least it could be at that expected level. And we know that in the fourth industrial revolution, or probably even going to the fifth, technology will be always playing the critical part as far as data interpretation is concerned. Thank you.
I can add something about the marine geology area. In terms of our expertise area in marine geology, we need much more exploration and investigation in the seafloor, because we are looking for mineral resources in the surface of the seafloor, and most of them are unexplored yet. And we have a very fair knowledge of the surface of the seafloor, of the geological processes on the seafloor, but also the interactions in between the geology and the ecosystems and the problems with the environment. No, in these terms, we need some the development of geophysical and geochemical tools for the exploration of the seafloor surface, but also areas in depth. For instance, for the discovery of new hydrothermal deposits or fossil hydrothermal deposits on the seafloor, but also to integrate all these tools of exploration to understand the distribution and the genetic processes of these mineralizations on the seafloor. And I think that this is a very important task for the future and future generations in Europe and in the world. Also to work together with biologists, environmentalists, and other people also engineering in this sector, that is the marine sector, is so difficult to understand, because we are working thousands of meters below the sea surface. Thank you.
Thank you. And we now have Catherine, who would like to add some points.
Thanks. Yes, it's Catherine Goodenough here from the BGS. And just to kind of link capacity and what capacity we need to the question in the Q&A about critical raw materials, particularly in Africa. Of course, we've heard from our colleagues in Botswana and South Africa that have a lot of geological information for their countries and really good capacity, but there are many African geological surveys that are lacking in capacity, that perhaps don't have the data that's needed to really understand the potential resources in their countries. And I think for all of us here working in partnership with geological surveys across Africa and working with them to ensure that their data are consistently well managed and that they're able to interpret those data in the context of the critical raw material mineral systems is something that's going to be really important over the coming years. And it would be fantastic if we were all able to collaborate on big projects to try and work on that kind of thing across Africa as much as possible. I see that as a really important way for us to work.
May I have one comment as well, because Finland was mentioned, and with regards to mineral system modeling, even though the tools and, let's say, artificial intelligence and machine learning and these allow us to integrate a lot of data and do powerful analysis, but I just like to emphasize the importance of the primary observation and the field geology. So the model can be as good as your data that you're putting in. So if you lose your grip on the real rocks, so you don't do much good modeling afterwards. So just bear in mind that some of the basic skills are still needed. Thanks.
Thank you. Yes, go ahead.
To that point? Yeah, my name is Howard Gautner. So we know that most of the very big occurrences are found around the world. So the critical minerals, they are in most cases, they are co-product of something else. This means that what I think is going to be very important is to have a proper mineral occurrence database, and where you know where you have the localities where you have some enrichments. So I completely agree with what Sako said. We need to have a mineral occurrence database where we know where the enrichments are, so that, and they tend to cluster, and they highlight us into prospective areas, exactly as we have seen in the examples on the talks earlier. This is my is an very important point, and this is a very, to create this database and to fill it with data is a quite hard work, laborious work, and also not very advanced science. You don't get very much publishable results out of that work, but it's very important. Thank you.
Thank you.
Sorry,
yeah.
Can I just jump on this question also, because at the Belgium we try to develop new capacity regarding the market analysis tools for traceability of the lithium and favorable predictivity as developed through the GeoEra lithium example that I presented, and also that Daniel presented with the CBA method. So these techniques, for sure, with the observation of the rocks and everything, is part of the new tools that we can use as geologists to do prospection for minerals.
Okay, thank you. We got another question contrasting strategic minerals and critical minerals. There is a strategically some consideration because critical minerals are not always the same as critical minerals, the strategic minerals. And there's a question here about the new trends. Like this one, this question is that the battery minerals continue to be in focus. However, it seems that the demand for other metals like iron and copper is also growing. So maybe can they be effectively be part of a domestic exploration? And what's your opinion on those strategic metals and minerals?
Yeah, perhaps I should try to answer this one, since I think I raised the point during the presentation.
Yes.
So I'm in the hot seat again. Yeah, so traditionally, strategic minerals have been minerals that have been associated with defense applications. However, I think that we are slowly moving away from this definition of strategic minerals. And like the person who asked the question says, yes, strategic minerals are minerals that can be associated with industries that do not only rely on the critical minerals. For example, we all know that an electric car has an electric motor and a electric or a battery, but however, everything else that goes around it is not maybe a critical mineral. It is maybe a strategic mineral. Electric cars will have dozens of kilos of copper wiring to connect all these systems together. And yes, copper is what I would consider personally as a strategic mineral, because don't forget that with the increase of any product that needs a critical raw material associated with it is an element or a raw material that is not on the list of the critical raw materials, but can be considered a strategic raw material. Now, iron was mentioned. Now, it seems that in terms of iron, worldwide production of iron, people are quite relaxed about it, and things are being produced at a steady rate. There's enough production to meet world demand. But when we come to copper, for example, that may not be the same as that for iron. Now, for example, we know that Europe is a copper producer, a much smaller copper producer, for example, than South America. But we do know that South America, and one of the typical examples is Chuquicamata, that is getting deeper and deeper and deeper, and obviously the grade is reducing because the ore body will eventually peter out. And so where do we start worrying about strategic raw materials, and when do we stop worrying about them? And this is something that it's up to policymakers to make sure that they have a good understanding of the whole periodic table, not just of some parts of the periodic table, and then from then on just make the correct decisions to implement investment opportunities. And what I'd like to say as well is we've seen that in this morning's talks that everybody seems to know where the next deposit of X and Y is going to come from. However, does anybody know where the next mine of X and Y is going to come from? I think that's slightly harder to answer.
Thank you so much for this for your points. Anybody else who would like to comment about critical minerals versus strategic minerals and your geoscience research?
Taufik again here from the CGS in South Africa. Yeah, I think one interesting trend that we saw as well in South Africa right now is that, you know, as we move towards, let's say, our climate mitigation scenarios. So South Africa is a very good example where we've obviously ratified the Paris Accord, and in the next 10 years, we actually have to reduce CO2 emissions by just over 50%. But of course, 90% of our energy is actually being produced from coal. So obviously we're moving quite significantly into renewables and batteries and so on. But you know, we've really now looked at this this idea of the just transition. So we still look at minerals like uranium and even coal as well. But now we find these associated technologies that can assist in, let's say, either beneficiating uranium more efficiently or using, let's say, coal more efficiently. So we're looking at, for example, carbon capture technologies. So we see this kind of trend with a lot of the, let's say, the standard minerals that we will now deem to be, let's say, strategic. So of course, gold stays, you know, quite significant. Platinum as well, even with the electric vehicles and also the normal vehicles as well, you know, the combustion vehicles. So very often there's a very fine balancing act that we need to do. And I believe there was a comment also made about a lot of the critical minerals are often associated with other minerals. So we've seen this with things like cobalt. So where we have, let's say, present day mines, especially in the platinum mines, they produce significant cobalt as byproducts. So obviously we can now make use of existing infrastructure. So I think really from our side, we start to see there's a very fine balancing act now, you know, just to like kind of work out, you know, how do we then, you know, deem a mineral to be strategic versus critical. But of course, the local economy is also quite important with that one. Thank you.
If I could just comment on the strategic and critical minerals, of course, an important point here is the scale of the markets. So iron and copper are enormous markets with mines all around the world, and companies, of course, undertaking exploration at the same time as mining. Whereas if you look at rare earths and lithium, while those markets are expected to grow, they are currently really quite small. And particularly for the rare earths, there's only really one company successfully mining the rare earths as a primary product outside of China. So there's the investment in exploration tends to be junior companies that are usually living somewhat hand to mouth in terms of their budgets and so on. So I think that's why geological surveys are much more important in understanding these critical raw materials, because we can do some of the background research, because the large mining companies aren't getting involved at that level.
Thank you.
One comment to that. Can I give one comment
yes.
to that? It's a very quick comment by Catherine, but one has to remember that strategic and critical minerals, there are some important differences. For example, let's say if you have a petrol-driven car, you can take away You can take away the doors. You can remove perhaps 100 kilos of iron from that car, and you can still drive it. However, this petrol-driven car contains also perhaps 1 gram of platinum in the catalyzer. And if you take away that 1 single gram, you are not allowed to drive that car anywhere in the world because it will not hold the emission regulations. So this means that platinum will be a critical mineral. So without, it's like a vitamin in the body. If you remove the small amount of vitamins, you will die. And that is why critical minerals are critical and in fact more important than the strategic in my view. And I think that EU has done exactly the right approach when they map out the concept of criticality. They look at the numbers of producers in the world of a large list of commodities, and those that have few producers, they are critical. Those have many producers are non-critical. I think that this concept is correct. Thank you.
Genevieve, may I just
Yes.
have one simple comment, short comment?
Yes, please.
Yeah, I think as geoscience institutions, we need to understand one simple thing: tools that can influence the policy as far as the trends of where things are going in terms of mineral consumptions. In Botswana, we are doing something what we call mineral accounts. That literally looks at the reserves of the country, their rate of depletion, and as well as that vis-a-vis what is the projected uses. And if we can look at the projected uses, we should be able to influence the government on a well-founded and calculated tool that can inform policy. So my conclusion is that we should actually undertake some of these projects and some of these assessments of our resources at a national level, because we've got a hawk's eye view of the entire mineral commodities for the country. And to influence the policy, let's look at our reserves, let's look at the rate of the depletions, and also look at some of the trends in terms of consumption, and we'll be able to actually influence the policy for the government as well. Thank you.
Thank you. Anybody else who would like to comment on this point?
Well, a short comment that is related to exploration and the strategy of exploration. So at least in Finland, it seems to be that it's highly dependent on the price volatility too. So if prices go up, so we see exploration campaigns and so on, and when prices go down, so things starting to get more quiet. And so in that sense, there's not a strategy much seen, and then it comes down that what are the national let's say strategic goals, and how you operate in this kind of world where prices are still dominating, and doesn't make sense too much with the strategical importances of nations.
Yes, that's right. Thank you. For this forum today, we are focusing on the future of geological surveys and what will influence the future of geological survey. And I noted that in all the presentation, every presenters and panelists raised the importance of data. And we have a question here related to data, and perhaps in particular related to the presentation from Finland, where the initiative One Geology was presented, because it can help in the discovery of critical minerals through the knowledge sharing, through the sharing of data sets. There was one question related to One Geology. Of course, they have a website, so we can find who are the countries participating in One Geology. But perhaps, Saku, you could mention a little bit more of the benefits of this kind of contribution for the data asset sharing.
Okay, thank you. I guess I could mention that GTK has been collecting geological data over 130 years, and of course the how we manage the data is one of the key questions, and as the questions that we need to answer are getting more and more complicated, so we need to integrate the data with, let's say, with environmental information and so forth, and those integrated data may be used in land use planning or whatever. But I mean, it's very crucial for us to consider that how we can integrate our data in national level and of course with European level, and that's there's been a lot of work with the Geological surveys and our sister organizations in European, and we see the value of integrated data and interoperability that is laying the basis for enhanced services for communities and businesses. But in global level, I think the One Geology is one of the let's say most important initiatives, and we are supporting that. We are engaged to provide our data to the global databases, and I think there's a lot of things to do, and there's a lot of good progress going on, and I think there was 120 countries that are providing data to the One Geology, and I think this kind of progress would serve the whole scientific community at large, and I think that's something that everyone should consider how they could integrate into this. But I don't know what was the answer to your question, but I see that the entity of large data sets is worthwhile creating. Thanks.
Thank you. The topic of data and data assets is really vast for critical minerals, and it's also essential to that we have a conversation about the data and the data management. So many of you mentioned the challenges of the data assets and extracting the information and intelligence from data assets. Do you have any recommendation for the future or a vision of the future for the data management for the research in critical minerals?
Well, if I may say one comment here for starters, that when you consider your database management and these kind of issues, so I think the next step is to have a third dimension in the system, so that if we integrate three-dimensional data, that should be somehow considered so that it's doable. Thanks.
Maybe I could just make a comment on this. I think, as we've heard, mineral occurrence databases and these kind of point source data are vital, and the more that we can make sure that those are in similar consistent formats across all of the different countries, that's obviously really important. But we've heard a lot about mineral systems, and I think the ideal is that we actually start moving beyond just the information about exactly what's there, what's known at certain localities, really into more of a holistic understanding of the metallogenetic belts, and several presenters have talked about this, and being able to look across several countries where we have a belt that is prospective for certain minerals, understand what the key prospectivity sort of targeting features are, and really work together to try and understand those underlying processes rather than just having sets of data in databases. So the databases are really important, but they're there to underpin that process understanding. I think if we can move more towards that, and of course Australia and Canada are really good examples of where that kind of work is being done, then that would be really beneficial both in Europe and in Africa.
Can I chip in as well?
Yes.
Yeah, I think making a follow-up of the statement, because I was also interested to share, I think we have had an opportunity to actually be shared with the European, Canada, let me say probably Australia as well, and the USGS on their satellite images. The one in Australia, they introduced it as a cube for Africa, whereby basically they realized that we tend to be having like a situation whereby if in Botswana I have access to some satellite images that I'm using for interpreting my 3D that can be able to do further analysis in terms of my deposits, then I would not be probably having a platform where I can be able to share it maybe with other countries within Africa. But then they decided to say they are going to segment Africa to make it easier for us to be able to access the information. And when you do the analysis and interpretation, you actually save the data on the cloud, and then you can have the information for free. But though obviously then Australia will have access to the information, but the people who they have put the information, they can be able to access it for free. So which means it entitles us, if I'm in Botswana, to be able to access the one in South Africa or access the one in Namibia, but I can be able to share the one in Botswana. Then that is another aspect that I would say is an ideal situation to be able to take as a trend of how we can manage the data in the days of now. That makes it easier in a sense, because when you put it in that cloud in that format, everybody will be putting in the same format. Whether you want to download it, it's accessible, and you know that when you upload it, is in a format that somebody else in another country can be able to access the same information. So that is the data sets that they have created, and which I believe is the trend of making it easier for us to be able to say we manage the data and we make it even more prompt for being accessible by other stakeholders. Thank you.
Thank you.
Can I just complete these questions too? Okay, yes. Thank you. So I would like to point out that what is really important in Europe is that we have several European projects, such as Horizon Europe, in which the surveys have developed several projects, such as one Geology, but also there is Mineral4U, there is a ProMine, and this is the base to develop database, unique database or identical database for all the countries, and to have consistent data that we can all use for the different projects.
Thanks. It seems like it's a big driver, all the data management to achieve our geoscience research for the future. I also noted that in almost all presentation, you all raised at one point the inevitable approach of using artificial intelligence and machine learning to extract the intelligence needed for the research on critical minerals. Though this comes with a lot of challenges. Could you please expand on the challenge of using artificial intelligence and machine learning in your geoscience program?
Maybe if I can start from South Africa, maybe just one interesting thing that we've seen recently, besides the satellite data usage, we have about 1 million meters of core, legacy data, and we've just recently acquired a hyperspectral scanner. So we're producing these very large, I don't know what you call this, petabytes, I think, of data. And of course, it's virtually impossible now for for a human to kind of work through that. So we're now in this new challenge of actually looking at this extremely large hyperspectral data set of trying to pick out very specific mineral systems, I think, number one, and then number two, trying to link that with the surface data. So one of the challenges that actually we get to a point where we maybe rely a bit too much on the AI techniques, and we start to overlook things. So one of the things is this principle of recurrence models, where we might have to do this several times, and at least occasionally rework some of these AI models and really look at them, systematically again and again. So this is something very interesting that we're starting to find now, and I think from at least from a South African point of view, where we're not very clued up on AI models, especially now these machine learning and agent-based model systems as well. That's something that we are now starting to really get to grips with. So there's this fine balance between having, let's say, humanize, and doing things old-fashioned, and then being assisted with these various AI models. Thanks.
Thank you. Is there someone else who would like to comment on the challenge of using AI for the research on critical minerals?
I may add something, in fact. some raw material were not prospected in the past, and the needs now, it's really focused on the database that we will compile at this time. So we had an example on the Iron for Raw project, is a European project in which we were looking at for indium, and indium was not specifically looked for in the past, so we had to play with the data and to define if we had more chance to have, regarding the metallogeny family of the deposits and the element associations, to have clue of presence for the substance or the commodity. Thank you.
Thanks. And I believe someone else wanted to say something about that.
Yes, I would maybe chip in as well. I think the challenges that we have had is that most of our data sets has been sitting for a couple of years in different formats. And that probably would be like an interpretation that you need to do first to be able to make it easy to integrate with another one, to be able to run the AI. So those are the elements of whereby you still need to be able to get the information. Some of the information probably in different stakeholders, they have not reached a level whereby they can present it for sharing. And those are some of the areas that you need to deal with to be able to appreciate the different models that they use to be able to extract the information. So I think it's a trend of having to appreciate first where the data set standard is at the moment. And if the standardization of that data set is not at the level where you would have wanted to put it within the AI, then it is also one of the elements that we need to deal with the challenges, because it affects the correctness of the data, the accuracy of the data, and the quality of the data. So those are some of the challenges that we have also experienced that we still need to manage. Thank you.
Well, one short comment, if it's possible. So in Finland, we are also using those old field observations to a certain extent. And that, of course, they are quite heterogenic, and that's one of the tricky parts of this thing. Most of the work is done, or the data is somehow compromised, or I mean, from it can be analytical, and those are more easy to handle. But those field observations and man-made notes are a tricky issue. Thanks.
Thank you. Is there anybody else who wanted to present an observation or comment on that? If not, we are also getting a lot of questions regarding the linkages between the critical mineral research and the circular economy. In particular, I got this question for you, the presenters today and the panelists. Do you think a circular economy is possible? And if so, if it's possible to achieve with the critical minerals, the question is when do you think it could be possible, and what critical mineral research is required to achieve a circular economy?
Maybe it's just from our side, that's quite an interesting one, because we've actually seen that this is being undertaken with the vanadium redox flow batteries. So in the Bushveld complex, there's quite a lot of projects that's looking at these, specifically the vanadium redox flow. And some of the new technology that has just come out recently is that, often you'd find that the anode material would need to be replaced. So these vanadium redox flow batteries are being produced, and in fact, the vanadium is 100% recyclable. So basically, obviously, they're using this for these off-grid type of development. And often when the batteries are kind of reaches the end of life, which is now maybe 25 years, which they're predicting, they are able to be brought back, or at least this is envisioned now. And the vanadium is recycled, and then obviously the anode is just replaced. So actually, we're starting to see that, at least in South Africa now with this vanadium redox flow batteries. Thanks.
Wow, super interesting. Anybody else who would like to comment about that?
Yes, unfortunately, the battery or any recycling story also goes associated with the NIMBY, which is not in my backyard. So traditionally, we want to recycle everything, but we don't want to do it in our backyard. So we send it off to less developed countries who we don't mind if they all die of some toxic poisoning. And this is something that is not conducive to a circular economy.
Yeah, I'd quite like to just add. Sorry.
Yeah, Catherine first.
I was just going to say, yeah, I'd like to add to that. Thanks, Avad, because I think it's a really important point that many people will talk about recycling as though it is going to be essentially the cure to all of our ills and it's going to allow us to not have to mine anything else again. But of course, recycling in itself is an industrial process that comes with its own energy use, its own environmental impacts, its own need to collect all of your ores, if you like. I almost think of it as urban mining rather than recycling. And there's a huge amount of research going on into that and into trying to develop those processes for a circular economy. But of course, for a lot of the critical raw materials that we're talking about, demand is expected to grow very rapidly, and much of the material that is in use is still in use. It's not yet ready to be recycled. It's in mobile phones sitting in drawers, or it's in electric vehicles, or it's in wind turbines that are currently active. So right now, and really for the foreseeable future, I think, whilst recycling is so important and the circular economy is going to be so important, we also have to remember that mining is always going to be essential because demand is growing so fast, and we need to keep putting more of these raw materials into the manufacturing system. And I think that's just really important for us always to remind people of when they talk about the circular economy.
Yeah, and I completely agree with Catherine there. As long as the consumption increases, the circular economy will not be the only solution. You have to put new material in. And then comes another problem that recycling in many cases aren't recycling, they are downcycling. So what you get after you have recycled is not something that you can replace primary production with, but you can use it to something else. A different product, usually of lower value. And that is why circular economy will never, you can't simply have 100% circulation of everything. Thank you.
Thank you about this point. In fact, the next, yeah, I see someone would like to comment on that too, on the circular economy. Yes.
Yeah, short comment, or actually two. I think I can see some challenges of economic viability due to increased material efficiency. For instance, 10 years ago, mobile phones were having about 10 grams of gold with them. And now it's due to material efficiency, it's about 1 gram. So where is the economy of recycling? And the other point is the energy used in recycling. So when you have more and more complex combination of elements and how much you need to use energy to separate them. So the energy balance needs to be considered as well. So sometimes primary materials can be more energy let's say, efficient to take out than recycle something. That's 2 comments from my side.
Thanks. Before I move to the next question, I just want to make sure that I'm not forgetting someone who would like to comment on the circular economy and critical minerals. Because in fact, the next question that I received is this one. What do you view is the role of raw materials as opposed to recycled materials in reaching a low carbon economy?
Can I answer that one quickly and just say it's essential? We can't reach a low carbon economy without using these critical raw materials, and that means we've got to mine them.
Yes, and I think some presenters today mentioned that it will never be enough. The recycling is super important, but it's never going to be enough to reach a low carbon economy. So the mineral exploration is so essential in this project of low carbon economy. Anybody else who would like to comment on the low carbon economy and critical minerals? Well, if not, then I have another series of questions, and this time someone mentioned that it's really nice today. We have presenters and panelists coming from geological surveys, so national geological surveys, but the question is about collaboration. What's the role of collaboration with academia or industry in your agenda for critical mineral research? Like, how do you engage with what's happening in universities or academia and of course industries? Do you have example?
I can answer to this question. The French Geological Survey is involved in several European projects, as I mentioned already. We work together. With Catherine, there is a paper that the BRGM published also on the rough earth. There is several studies on lithium between the GTK, the BRGM, and others. And the BRGM also support and he's involved in the PhD and master thesis in France, but also elsewhere in Europe and in Africa also. So it's part of the job of a survey, basically.
Genevieve, can I comment?
Yeah.
Yeah, I think partnerships are critical, and not just with academia, also with the private sector. More especially that if you look at the private sector, they do have some of the data that normally flows to the geological surveys that normally becomes pre-competitive data after they've submitted it. But one important aspect I will give through an example that in Botswana, we currently have a partnership with the private sector, one company that we're working with. And it is exactly in the space of mineral prospectivity mapping. And we realize that if you look into the past, the NPM or mineral prospectivity mapping or NPM has been rapidly growing. In the past, it probably dealt with geochemistry, and nowadays, as it grows, the integration of not just geochemistry but geophysics and all the other data sets becomes important in creating these models of mineral prospectivity. So what we are realizing here is, from the private sector, we are helping them to design strategic exploration strategies through mineral prospectivity models and mineral prospectivity products. We are helping them to design these exploration strategies by providing them with data that normally they wouldn't have, and by so doing, they develop this critical tool and models for the country, and to reciprocate the private sector as well. They will actually now share and share this data as well. So there's data sharing. There's advancement of certain techniques. There's advancements of research as well. So this is quite critical that we actually partner with the private sector. And in Botswana, like I said, we already have a partnership that looks into that. That is actually one of the companies actually doing that. I just wanted to give that example where we believe it is a win-win. They are developing a tool. We are giving them data. And they are using data that they also are bringing on board. And when at the end, they will submit all the data to us as well. So it's a win-win all the way. So partnerships are critical, more especially when they are designed along the win-win way. We leverage our strategies, we leverage our mandates as the institutes. We can take things further. Thank you.
I would like. Oh, sorry. You first.
No, go ahead.
Okay, I would like to add something about our activity from the Geological Survey of Spain. In the marine sector, we are in cooperation working with the universities to do master thesis or doctoral thesis on different areas for example, in the Canary Islands for study of manganese grass, but also with the Eurogeo surveys with the, for instance, the Geological Survey of Sweden to study concretions in the Baltic Sea, or with Russia to study mineralizations in the Arctic Ocean. And we are forming a pool of researchers and students, because for us it's very important to explain our activity to the new generations of geologists or mining engineers, etc. And also we are working in cooperation with the industry, for instance, to develop methodologies for the recovery of critical metals from the mineralizations, not only at the sea floor. We are working with universities from the South America, for instance, Buenos Aires or Chile universities, but also on land deposits, working with the mineralization in the Iberian Pyramid Belt to extract cobalt or gold for the massive sulfides mineralization, developing new models of technological models for the extraction of these metals. Thank you.
Thank you, Catherine.
Yeah, thank you. I was just going to sort of echo what everyone else has said, really, which is we're involved in a lot of academic partnerships and partnerships with the private sector, as well as partnerships with other geological surveys. And I think that it's so important. It really is the way forward to make sure that you're engaging with all the different organisations that could be involved. But the issue, of course, is always one of funding. And European Union funding has been excellent, perhaps slightly less helpful for us in the UK, though we are still eligible for Horizon Europe and do look forward to working with many of you again. But other sources of funding that allow us to go beyond Europe and looking at potential collaborations in those areas, I think are really important. And opportunities like the World Bank's kind of climate smart mining initiative, for example, are areas where it would be great if we could collaborate to build opportunities in those sort of areas as well.
Thank you. Someone else who would like to present on the topic of collaboration?
Yes, the one aspect that it has not arisen yet is the infrastructure, research and development platforms. And as a GTK, we have a kind of unique combination of geological survey and mineral processing pilot plant. And what we are seeking is that we would get more geometallurgical data that could be actually incorporated to our mineral databases in order to estimate that whether deposit is or occurrence is how it could be beneficiated or processed. And that's something that we are looking for in our collaboration with universities, startups, and mine operators. So I think with that data we can also predict what are the possible environmental impacts of extraction when we know the quality of ore that will be extracted. Thanks.
Maybe I can also chip in.
Yes.
Okay, we do in Botswana have the collaborations with university. Maybe just to add on what also Piso said, we do have those with universities, because another example, this one I wanted to include it because it was also involving NASA. We had a meteorite that landed in Botswana, and the University of Botswana Science and Technology was involved. We were involved, and NASA was involved, and that is the discovery. We had to find out how it actually landed in Botswana and how the area that was affected, whether it could be leading to any further tremor or anything that could happen to lead to the resultant of that. So the data sets that we end up building in terms of that collaboration is needful. Apart from that, if there is any other analysis or maybe that you do on the laboratory, we not only use ours. We also used the university laboratory. We also had one of our employees who even had to go abroad. Is it Spain, whereby he had to do the analysis. So that's why at the end of the day, the collaboration in the academic field, not only just maybe locally in the country, it also involved some international bodies on that research. Thank you.
Thanks. Well, I'm really glad you raised that point, because actually the next question that I received, it's also about collaboration, but more specifically to Botswana and South Africa. And the question is, what's the role of your Geological Survey organization in Botswana and South Africa to help local communities with the change of land use patterns? What kind of collaboration do you have with your local communities?
Okay, maybe I suppose I'll start. Yeah, no, that's quite important. I mean, maybe if I can just add on quickly, one of the things that we are seriously finding in South Africa right now is that obviously being a developing country, government funding is obviously very limited. So we have to be very efficient with the expenditure. So, that goes without saying that in terms of the collaboration, no duplication of, let's say, objectives can be, sort of allowed. So obviously we have to work with collaborative efforts to overcome certain things. So what we have seen now, especially in a lot of the eastern parts of the country, so South Africa has very many policies that maybe look towards the infrastructure and land degradation side of things. And of course, this is maybe some of the poorest areas in terms of the communities. So in many of these areas, through possibly the mining and linked to mining, there's massive areas of land degradation, which obviously now it sterilizes the land, can't be used for agriculture, and it leaves quite a significant negative legacy behind. So one of the things that we have to do now is we have to be very integrated in terms of our program. So that means that when we look towards, in terms of, let's say, mineral development, it has to be looked at this cradle to grave side of things, number one, and then also the this cohabitation, I suppose, between mining and the communities. So that becomes very important. So what we've started to do now, and it's something relatively new, it hasn't really been done in the past, but we have a lot of engagements with the community. So that is both, let's say, before any development happens, during development, and again after development. So, we are restricted because being a government entity or state entity, this is something that we really have to do now. So this is something that we're doing in South Africa quite a lot. And it's something that's really now becoming a new feature in terms of how we plan as well. So quite a significant portion of our budget needs to go to this, the CSI, or this stakeholder engagement side of things. Thank you.
Thank you. Botswana, would you like to add something about your collaboration with local communities?
Yes, I think one of the critical things that Geological Surveys and BGI is aiming at is to influence the growth of our local communities by making sure that locally available products, slates, construction materials, and other things like that, we are able to identify those, and we are able to facilitate the local communities to actually get into exploitation of those. Of course, there are challenges there. There's some of these local communities, they don't have the technical know-how. So we must actually make sure that as we develop these projects and as we advance them, we do them to a level where the technical details of the projects are sufficient to get to the next stage of exploitation. Another challenging thing, obviously, it is the legislative framework of how can they now exploit these commodities within where they are, without necessarily degrading the environment and other things like that. And that's where now we enlist the regulators like Department of Mines and other organizations that can actually help us come up with some of the conditions, exploitation of these commodities in a safer and a better way. And I think BGI has actually started and gone a long way in already identifying several deposits in Botswana that we are actually targeting that the local communities will be able to exploit. And we are at a stage now where it is just working through the modalities of making sure that these things will be exploited more efficiently. And I think that is quite critical, that a geological survey educates the people as well on geohazards, on other aspects that as the communities grow, as towns grow and other areas grow, they are able to be grow into areas that are more stable, that are more safer. And we are working with local authorities, not only advising them on the extent to where they can actually not only advising them on the land that they want to expand into, but also educating them into the process of integrating geotech and geohazards into the land planning policies, so that we sit down with them, we advise them, we advise them on many things in that regard. Another interesting aspect, obviously, is earthquakes. Botswana, for instance, is viewed as seismically stable. But once in a while, we do get an earthquake coming through, and we take it that it's our responsibility not only to report the parameters of the earthquake to say it was at this magnitude, it occurred here at this depth. We actually go an extra mile in actually educating people about earthquakes, educating people about some of these some of these things that are quite critical. And I do and I do agree and do believe that geoscience must impact the local economy in a more profound way. There are instances in the past where through our research as well, we realized that we're depleting and really hurting the environment of our rivers. And we did a study that actually now showed how the impact, how the environment was being negatively impacted. And that influenced the decision of the government to say, we are going to go to manufactured sand. And we did another study on manufactured sand, identified quarries, and handed it over those to quarries. So the impact is far-reaching, is important, not only advising to prevent environmental degradation, but also to actually improve the local economies to grow. I'll leave it there. Maybe the SOHO can come in as well.
Okay, maybe just to add on. It is also within the responsibility of BGI to present the Geological Museum. Currently, it's at a piloting stage, and the museum is for targeting the community even from the elementary level. So in that case, people will be probably have it in a situation that will be more informed to be to build knowledge economy for the country, such that people will have more understanding and be in the same page of understanding what is geoscience and having its preparedness even as the community grows. So that one is the area that we are also focusing on in terms of building the museum for educational purposes. Thank you.
Thank you. Thank you very much, South Africa and Botswana, for your comment on engagement with local communities. I would like to open this question to the other surveys if you have any specific points to bring on engagement with local communities for your research agenda on critical minerals.
Genevieve, before they come in, one additional point that I want to add is that I think the survey must also be highly involved in development of kids by getting involved in critical programs that are actually targeted at influencing the career for kids. They must be there for schools and other things. They must actually be part of that, so that geological understanding starts even at an early stage. And at BGI, we do participate in programs. There's one program called Science, Technology, and Engineering and Maths called STEM that we are heavily involved with. We are heavily involved with some of these public shows where we've got stalls and we showcase some of our things. Thank you. Right,
that's a really important point. All the STEM engagement in geoscience and to advance the critical mineral research. Any others would like to comment about that? If not, I can mention one last question, and it's for everyone to comment on this one. And again, we're back to data sets. The question is posted on the live chat. So, which data sets have you found missing in your assessments? Which specific data collection do you expect to conduct in the coming years? So, this will most likely be the last question for this live session. So the floor is open to every presenters and panelists. So in your opinion, what will be the next data sets that you're most likely going to collect to support your research agenda?
maybe I could comment on, and this is really a comment on the last two questions, because these things depend so much by the country that you're talking about, actually. So I'm sitting here in a country that is not overly keen on mining. And so going back to involvement with the communities, any community that you go to and say there is some exploration going on here for a potential mine, that's a very risky thing. And in the same way, some of the data sets that one might wish to have for exploration for critical minerals, in the UK, for example, we don't have a good airborne geophysical survey, which of course does hamper the understanding of national resources. And I think it is a really interesting point that data are so varied across different countries, depending on what that country's priorities for their geological information are. And I think this is one of the things that makes it harder to understand those wider mineral systems, is because national data sets are so varied. And I've noted some comments in the chat about the outputs of European projects and how some people have been saying they're not very useful. But I think part of that is because these projects that have been going on, that many people have mentioned over the last couple of decades, to bring together data on critical raw materials, they've had to start from such a complicated and such a varied sort of base that really, in fact, they've achieved a huge amount. But it may not look as though it's that much progress because of the difficulty of uniting all of those different countries and all of those different data sets and approaches. And really, it's a question now of building on that, I think.
Genevieve.
Yes.
I think, if I may quickly come through. Yes, I think Kathleen is right that probably it might be country specific, but I also want to believe it might be continent specific, more especially when it comes to geochemistry, geochemical data. That is, if you look at my earlier comment to say that mineral prospectivity, some of these models, it used to depend heavily on geochemistry. Now we are integrating other data sets, but there's such a paucity and lack of geochemical data in most of the African countries that when you look at the logistics of collecting this data and the analysis and the quality controlling all the aspects, the process of actually handling it, and it is probably one of the things why it's quite expensive. You can imagine in remote parts of Africa, if you try and go and collect data, what all sorts of logistical problems will come to the fore. And I think geochemistry is quite one area where countries, even in Africa, can collaborate to make sure that they actually get around the logistics of collecting it, sharing the labs, more especially the labs, where they can actually leverage. And in say in Botswana, we've got this capacity, in another area there's this capacity. We can look at making sure that we collect the samples, we can actually analyze these samples collaboratively. So I think to me it will be geochemistry. Yes, geophysics, you can fly, you can collect it. Yes, there are some ground-based techniques that if you can't do on the ground for geophysics, you can actually fly and other things like that. But geochemistry, I think, is one important aspect as well.
Excellent, thank you. So yeah, more geophysics, more geochemistry. We only have 3 minutes left before the end of this live session, and I don't want the session to end abruptly. So I would like to take just a few minutes to thank the organizers of this forum, Advances in Critical Mineral Research, a forum in memory of Victor Lobson, who passed away abruptly last fall. And I want to also thank the organizer, Chris Lawley, who's been organizing all the sessions, the panel, and all behind the scene. He's also one of the moderators today. Thank you to all the presenters and panelists and the plenary speakers, Daniel, Javier, Sakou, Catherine Blandine, Avert, Lesogo, and Pusso, and Tofik. All of you, thank you so much. And also Layla from AGI, who's also organizing this forum on this platform. Thank you so much, Layla. It's been a great session with you. And one last thing, that I want to mention is that if you're a participant today, you can get a certificate of participation. So Layla posted the link. If you would like to get this certificate, it's available to all participants. You can feel free to request this certificate. Mm-hmm. And I think it's on that positive note on the future of the critical mineral research agenda that we will end this session today. And it's been a great session, and I wish you a great day for the rest of the day and have a nice weekend. And watch out, next week we will have another session, and the last session for the Asia and Oceania region. So watch out. There will be another session and a conclusion to this forum on critical minerals. Thank you. Goodbye.
Thank
you.
Thank you very much.
Bye-bye.
Thank you.
Bye.
Bye-bye.
Bye.
Goodbye.
Bye.